Hey students, time for lesson 3, numbers in exponential form raised to a power. So I did the student workbook. So here's the slide deck one. So we know how to take powers of powers. That's what we're going to learn. We're going to know that a product is raised to a power. Each of the factors is raised to the power. And then you're going to write simplified, equivalent, numeric, symbolic expressions. You're going to write expressions from your knowledge of powers. Okay? So let's assume we have 3 raised to the 4th power. So 3 times 3 times 3 times 3. We know that's an exponential notation. Now, what if we have 5 groups of 3, right? So let me get my face out of the way. So if I have 3 to the 4th, 3 times 3 times 3 times 3, times 3 to the 4th, times 3 to the 4th, times 3 to the 4th, times 3 to the 4th. I have 5 groups of 3 to the 4th, and I would write that as 3 to the 4th raised to the 5th power. Okay? So that's an exponent raised to a power. Okay? So we're doubling up here. It's like mind-blown type stuff. So simplifying it is pretty easy, right? All you got to do, 3 to the 4th raised to the 5th power, write it all out. So like I did before, here's 3 to the 4th times 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 3 to the 4th. What would that look like? How many 3's do I have? So 4, 8, 12, 16, 20. 4 times 5 is 20. So I have 20 because there's 23's. All right. So why does it become 4 to the top? Why does 3 to the 4th raised to the 5th power become 3 to the 20th? Because we're multiplying the exponents. Okay. Instead of writing out all of these 3's and counting them up, I can say there are 5 groups of 4, which is one of my definitions of multiplication. 5, a number group of another number, is just multiplying that number. Okay. So the power rule of exponents, that's our 3rd law if you're counting. The power rule tells us that to raise a power to a power, you multiply the exponents. And just like in the 1st and 2nd rule, when you're multiplying or dividing exponents, it doesn't matter what the base looks like as long as it's the same. Okay, so here's some examples. 1.3 to the 3rd raised to the power of 10 would be 1.3 to the 3rd times 10, which is 1.3 to the 3rd. Right? If I have 10 groups of 3 of these, I would have 30 of those. If I have 8 groups of 5 negative 2's, then I would have 40 negative 2's. If I have 4 groups of 17 S's being multiplied, then I would have 68 S's being multiplied. If I have, for any number, raise any number n, if I have n groups of x raised to the nth power, then I have x raised to the m times n power. So we could show how to do that by saying so the product rule of exponents, right? Can you show that 5 times 8 to the 17th is 5 to the 17th times 8 to the 17th. So this is our distributive property, really. 5 and 8 are both being raised to the 17th power. So 5 times 8, 17 times. I do the magic of commutative math, and I move all the things around, and all of my 5's are in one group, and all of my 8's are in another group, and they're all still being multiplied. And I'm going to split them apart and say 5 times 5 times 5, 17 times 8 times 8 times 8, 17 times. That means I have 5 to the 17th times 8 to the 17th. So if I have something in the parentheses raised to a power, I can split it apart. Okay? And this just proves it for us. All right, so that's 5 minutes. I'm going to stop here and move to the next slide.